Welcome! This is Algebra 2, Unit 4.1. What is the effect of changing a value when you're graphing a over x? I bet you already have a guess. If you've been doing transformations with me, you do. Okay, so let's just look at a parent function here. 1 over x would be graphed this way. Put a negative 5 in there, it would become negative 1/5. Negative 1/2. 1 over 1 is 1. 1/2, remember, if you're dividing by a fraction, you flip it, skip, flip, and multiply. So that would become negative 2 and negative 5. Same thing over here. We plug these in. It would be 1/5, 1/2, 1, 2, and 5. So if we go up there to graph these, what we find is that over here at x being 5, we're down at 1/5. X being 2, we're at 1/2. At 1, we're at 1. At 1/2, we're at 2. At 1/5, we're up here at 5. Okay? So that part of the graph is making almost like an L shape. Okay? Now, on this part of the graph, does the same kind of thing, but it's down here in these negatives. So it would look something like that. Okay? Couple things I want you to notice. This is called a hyperbola. Hyperbola. How you would spell that is Hyperbola. Hyperbola. Okay, the domain. Interesting. How you would list the domain is that, do you notice we can't have a value that's equal to 0 for the x because we can't have a fraction with 0 on the bottom, it's undefined. So we list this as x cannot be 0. Interesting thing on y, we find that y can't cross this x-axis, so y can't be 0 as well. Is there symmetry in this? There absolutely is. If I draw the xy line right across here, x equals y or y equals x, this graph is folded right off of that graph, and that graph is too. You probably saw it right here, that they were inverses of each other. So that shows the fold line on there. Okay, so the symmetry is on the line y equals x. When is it increasing and decreasing? Super important concept in math is when a graph is going down, going left to right, then it's decreasing. And as you notice on this graph, going from over here, even though you're not very far over, to here, it is going down. And from there going on, it's going down. Same thing here, it's going down, it's going down. So it is decreasing in every area. Okay? End behavior is something that we want to talk about. As x goes towards infinity, positive infinity, f of x, interestingly enough, is going towards 0. Going this way, well, I guess that we could, going this way, as x approaches 0, it is going to, f of x is going to positive infinity. Down on this side, as x is approaching 0 from the negative side, f of x is going towards negative infinity. And down here, as x is approaching negative infinity, f of x is approaching 0. So when you see end behaviors approaching a number, you know that you're dealing with possibly a hyperbola. Otherwise, you could be dealing with a couple other functions, but when it doubles up this way, it's a hyperbola. Okay? Next thing, to graph them, we would just plug in points. Plug in -4, that would be a -1/2. -2 would be -1. Negative 1 would be negative 2. Negative a half, again, skip, flip, and multiply, so that would be a negative 4. If we plug in the positives of those, we would have 4, 2, 1, and 1/2. Okay, you may have to actually plug them in to see that. So, before I go to graph it, I think of my parent function. I also think of what I showed you on that front page, a to the x. What has my a value done in transformations? Okay, so that's just a little clue there. But as I look over here, I'm not shifting left or right. All I'm doing is putting in these points and they're expanding. So when the x value was 1, I'm up here at 2. When the x value is 2, I'm out here at 2 still. So I'll be honest, when I grade these and I see a stretch right there, the stretch is going to come right through on that axis of symmetry. So I know that it should be further out than when I've got the parent function, which has a 1. So it's got to be stretched further out. So that's what I look for. Go through your points. It will still come in close. Well, it won't hit it, but it will come in close to your axis there. But it's further out through the origin. On this other side, if we plugged in the points, we'd find the same thing. It's out past that 1, 1 point of the parent function. Still comes in very close to the asymptotes. If we have a point 4, I hope you're already saying that's less than 1. That would be a shrink. And you'll find that it truly is. At negative 0.4, we're at 1. At negative 1, we're at negative 0.4. So we're inside. I hate to do it in the same color, but I'm going to. We're inside of that parent function, so it would be in here that a shrink occurs. Okay? They still both approach the same asymptotes, but when it shrinks, it's real close to this origin. When it stretches, it's farther out. All right? So now we have g of x equals a negative 2 over x. I hope you already know what's going to happen. If you're saying, oh, my parent function's like this, and negative in front means that I'm going to reflect this up there, that down there. Let's see if that happens. I'm pretty excited. If you're thinking that way, plug in a negative 4. Negative 2 over negative 4 would be, bingo, positive 1/2. Plug in a negative 2. Negative 2 over negative 2 is 1. Plug in a negative 1. Negative 2 over negative 1 is positive 2. Plug in a negative 1/2, and you would have 4. So we can see by this one what's happening. It's still stretching. It comes out here to negative 2 and goes up to 1. At negative 1, it's up at 2. So it's still stretching the distance across the origin, but now we're in this quadrant and this quadrant. I didn't go ahead and put in those points. You can if you want, but it's stretched and it's gone to the second and fourth quadrants compared to the parent function. Now again, a negative here, but a shrink. All it's going to do is shrink it in across this origin, but it's going to be in the second and the fourth quadrants because it's negative, and that takes my parent function and flips it over the x-axis. Okay? Aya drives 30 miles to work. Commuting time depends on the average speed. Her average speed varies with conditions. Write and graph a function, TR. So I'm looking at my time being dependent on rate. So I want to get the time alone, and my input would be the rate. So I divide by rate on each side. And I get that my distance divided by my rate equals my time, which is dependent on the rate. Now, every day, this is going to change by the conditions. It already said that. So some days, she'll have an average rate of 10 miles per hour. Well, it's 30 miles to work, so 30 divided by 10, this is my actual formula. 30 divided by 10 would be 3. 30 divided by 15 would be 2. 30 divided by 30 is 1. 30 divided by 60, whew, I hope the speed limits allow that, is 1/2. So as we go over here, let's count by 10s, 10, 20, 30, 40, 50, 60. That would be my rate. I know that because my independent is always on my horizontal axis. My time, I'm assuming this is, it's miles per hour, so it would be time in hours. Okay, so we go 1, 2, 3. At 10, we're at 3 hours. At 15, which would be halfway between 10 and 20, would be 2. At 30, we're at 1. At 60, we're at a half. So you can see this is a hyperbola. Now my question is, why aren't we graphing over here in the negatives? Hopefully you're talking about real world and you're realizing, well, we couldn't have a negative rate or a negative time. Okay, so that kind of problem falls there. Also, you'll see this with rates on irrigation, rates on filling tanks, all sorts of stuff. It's really a good bit of math to understand.